One of the gas laws is Boyle's Law. This video will cover how to do problems involving Boyle's Law. As the pressure of a gas goes up, we could ask the question, what happens to the volume at constant temperature? The volume of a gas, if you raise the pressure of it, is going to go down. They're different. You can think if you raise the volume, the pressure is going to go down. The number of collisions inside of a container will be smaller as the container gets bigger at constant temperature. So the volume goes down. So we can kind of visualize it this way. As the pressure goes up, the volume goes down, assuming we're not changing anything else. So they change in opposite ways from one another. One goes up, the other goes down. There's a name for this. These properties are inversely proportional. Things are inversely proportional if they change in exactly opposite ways. Here's an example of something that might be inversely proportional. How many miles you jog per day and your weight. That might be something that would be inversely proportional. Most people who jog 40 miles a day do not have particularly high weights. Or perhaps the number of things you buy and how much money is in your bank account. Those would be inversely proportional. As one goes up, the other goes down. Inversely proportional. So the formula for Boyle's Law is this: P1 times V1. Anytime you see a formula here that just has letters up against each other with no mathematical symbols, of course that would mean a times. So P1 times V1 equals P2 times V2. What this is saying is that we have like an initial condition before we do anything to it, and then a final condition after we do something. So this is known as a ratio law. A ratio law compares something before and after. Before, and if we do one thing, if we double one thing, what happens to this other thing? So in a ratio law, we compare the before and the after. And with any ratio law, the units, I guess with most ratio laws, the units don't really matter as long as they are consistent units. You could use, for pressure, you could use torr, atmosphere, kilopascal, bar, millibar, whatever you want. Same for volume. You can use hogsheads, gallons, liters, milliliters, deciliters, or whatever you like. So, but it's got to be consistent. That means whatever volume you plug in on the left, you have to plug in on the right. So, if a problem has gallons at the beginning and liters at the end, you have to make them the same before you can plug them into the formula. So, yeah, that's just another example like the ones I just gave. But one thing to remember about Boyle's Law that's really important is that it's only true at constant temperature. Notice that temperature is not in the formula, and the reason it's not in the formula is because we're assuming that the temperature is not changing. Also moles, anything that's not in the formula has to be constant for this to work. So, here's an example of how you would do a Boyle's Law problem and what it might look like and how you would know that it was a Boyle's Law problem. What is the volume of a gas at 25 atmospheres if it occupied a volume of 250 liters at standard pressure? So, when you come across a question like this, you might not know that it's a Boyle's Law problem. If you're taking a test, it's not going to say this is a Boyle's Law problem. So how do you know that you have a Boyle's Law problem? Well, you have to read the question. You read the question and identify the different units in there. So the question is, what is the volume? Volume. We are being asked to find a volume of a gas at 25 atmospheres. That is a pressure. And it wants the volume at 25 atmospheres. So these two go together. Those are both ones or both twos. It doesn't really matter. Those go together. The ones and twos don't matter. What matters is that you have the right thing with the right thing. And it says if it occupied a volume of 250 liters, that is a different volume. At standard pressure, that is a different pressure. So these go together, so we'll call these ones and we'll call these twos. Again, it wouldn't matter if you call them the other way. The reason I'm doing it this way is because it seems to be that this was the initial state. It started at standard pressure and we're going to change it to 25. So what we do is we write down Boyle's Law, P1 V1 equals P2 V2, and we start plugging in the things that we know. P1, pressure at the beginning, was standard pressure. So that would be 1 atmosphere, or 760 torr, or 14.7 psi, or whatever. But how do we know which one to use? Well, remember that we have to use the same unit here as we do here, so we might look to this unit and see what it is, and that is atmosphere. So we're going to have to use atmospheres on the right, so we should go ahead and use atmospheres on the left. And that's nice because standard atmospheres is 1, which makes this an easy problem to do when you have to multiply or divide by 1. V1 is right here. It's 250 liters. And that's going to be equal to P2, which is 25 atmospheres from up there, times V2, which is what the problem is asking us to find. So what we're going to do now, we've plugged everything in, now we just have to solve it. So we've got to get the V2 by itself. So what we're going to do is we're going to divide by the 25 to get the V2 by itself, which means we have to do that to the other side as well. So we have 1 times 250 divided by 25, which I'm going to go out on a limb and say that that's about 10. So V2 equals 10. I believe we can only justify 2 sig figs, so we'll underline that. 10, and the unit is whatever unit we had before. We plugged in liters, so we're getting out liters. 10 liters is the answer. By the way, one thing I didn't really say, but should have. How did we know that was a Boyle's Law problem? Well, once we identified what all of our variables were, we had volume, pressure, liters, and pressure. And so once you identify those things, you'll see that those elements that it gives you are going to match one of the formulas. And so that's how we knew it was Boyle's Law.